Okay, guys, today we're gonna talk about backtracking, and for the following 10 videos, I wanna do videos about backtracking. I still owe you guys a video about tries that I'm gonna post as well. Backtracking is the hardest problem I'm gonna approach so far. It's really hard. Uh, it's a it's a flip to to recursion problems. What I mean by that is that it's we still use recursion but in a different way. Backtracking problems usually refer to situations where you want to test all the different possibilities exhaustively, and backtracking is the way to go. So it's a recursive way of testing all the different possibilities, and that allows us to solve a bunch of problems. I thought about trying to explain how backtracking works. I'm gonna give a brief idea of how it works, but I think I'm not the most qualified person to talk about how backtracking works. So in the description below, I put a link of a class at Stanford, which is very good. It's not if you understand recursion, you can definitely understand that it's nothing out of this world. Out of this world, and I think the teacher does a very great job of explaining backtracking. It's called CS61B. I think is their the algorithms class at Stanford, and he does a great job of explaining it. So I think it's if you are not understanding how backtracking works, I think it is definitely worth spending 20-30 minutes. You can put on 2 times the normal velocity and understand what the Stanford professor is talking about. I think it's much better than me trying and struggling to explain to you guys. But now I'm gonna solve a problem that is really interesting. So this is our first problem in backtracking. I'm gonna show you guys a graph, as you can see this tree here, of how it works. But funny enough, we're not gonna use trees. We're gonna use a different technique to solve this problem. But just to get the idea, what is up? We're gonna calculate all the subsets of a given set, uh, also known as PowerSet. If you ever took discrete math class. So what is a power set? Is all the combinations that we can do, that we can organize A, B, and C, where the individual elements are unique. So for example, if I had A, B, and C B A, that wouldn't be a unique set because we're repeating the characters, just the order is different. So the order, when we're talking about subsets, the order doesn't matter. So A, B, C, and C, B, A doesn't matter. It's the same thing when we're talking about sets. So we want to think about all the unique ways we can organize these 3 elements, and I'll go straight to the output. So we can do, for example, CBA or ABC, same thing. AB, AC, just A, BC, B, C, and nothing. So these are all the possibilities we can have of different sets with these 3 elements. How does it work on a conceptual level? We can either pick or not pick, and we do this over and over again. So let's suppose we have this set. We don't pick A, so we go down this tree. So we don't include the. We still don't want to include B, so we go down to C. We also don't want to include C, so we go here. And that's the empty set. It means we didn't pick anything. And that's one of the elements of the subset. Now let's suppose we don't want A, we don't want B, and we do want C. So we have C as the output. And you do all the different possibilities. So you can either pick A or not pick A. You can either pick B or not pick B. You can either pick C or not pick C. So after you've gone through all these possibilities here, you've reached the power set. and it's a very interesting problem, and I think it's the simplest of the backtracking problems. So let's now take a look at an actual example. I also want to take a look. So this I took from Lit Code. It's a general approach of solving backtracking problems. So usually you guys will pick a starting point, and while the problem is not solved, we're gonna check. We're gonna start, for example, with the first element. We'll check if we can take that path, because for other problems we're gonna see we might not be able. We make a recursive call to explore all the possibilities with that first element. So here, let's suppose I pick 1. I make the recursive call to make all the to see what are all the possibilities with the rest elements. So with 2 and 3. And then I undo the current move. So this undoing is pretty much so I tested this. I tested this. Okay, so I got this output. Now I'm going back and trying this. I'm going back and going here. It's unwinding the choice you made. And if nothing that you tried works, you return false. So I thought this was a cool framework of how to approach backtracking problems. You can also take a look at the Stanford class I talk about. I think maybe it's even better than this approach. But the idea is, at first you think, what the hell is going on? But I think you gotta understand the framework for one problem. So let's say you understand for subsets. Once you got how it works for subsets, you're good, because the pattern repeats itself for all the other backtracking problems. But without further ado, let's go to an actual example. So here I already have the code for calculating the subsets. So here I have I'm creating a object solutions, an array 1, 2, 3, and then I call it and print it. So let's take a look at it. So I call subsets, and I create a list called lista. I didn't call it list because it's a keyword in Python. So lista is just a list. It's list in Portuguese. So we have an empty list, and this list will contain our answer. So this will be, so I already ran it beforehand. As you can see, we got the right answer. So this outer, let me click here. You see this highlighted square brackets? This is listed. So this is the outer array that is gonna have all the different possibilities. Then we call backtrack. So backtrack, remember, is testing all the possibilities. So we're gonna throw lista, we're gonna throw an empty array. So this empty array will have each individual possibility. We're gonna sort the numbers. It's not really necessary sorting the numbers, but I left like this because for most backtracking problems we have to sort a lot of backtracking problems. So I just left this as part of a framework, a template I use every time for backtracking problems. And we also send the start. Where do we start in this array? So we start at the beginning, we send 0. After we are done backtracking, we return lista. So in the end, we want to have this one. Okay, so then we go to backtracking, then things start getting interesting. Just for you guys to understand what's going on, before I started the video, I printed what's going on in temp list for each iteration. So as you guys can see, each iteration will have the different elements of lista. So you have 1, 2, 1, 3, 1, 2, 3, 1, 2, 1. You have all the different possibilities, and you're gonna add those possibilities to lista. So when we start, we have temp list is empty. So we're gonna add a copy of temp list to list. And why a copy? Also, I think I'm not. I was when I first did it, I didn't make a copy, and it didn't work. I asked on Stack Overflow and I got really good answers. So I really recommend you guys. I'm also gonna refer in the description to take a look at my question on Stack Overflow. But pretty much, if you don't make a copy, you're gonna reference this. You're gonna always have the same reference to temp list, and when you pop, you're gonna pop temp list, and in the end, you're gonna have like an empty uh, a bunch of empty arrays. Just for you guys to understand, I'm gonna take it out. You guys will see what I'm talking about. So see what it's doing, because I'm always popping. When I copy, I create different copies. But if I pop here, it's gonna pop here. If I don't make a copy, like they are all being referenced by the same variable. So when I pop a one array, I'm popping for all of them. So they're referenced to the same thing. When I'm making a copy, I'm creating new arrays. If you want like a better answer, I really recommend the Stack Overflow answers the guys gave. And then here's the thing you're gonna see in every backtracking problem. So you have an outer loop. You have an outer loop where you have start and length nums plus len nums. So you're gonna go from 0 to len nums for each iteration. Then you're gonna append 1. So let's look at here. You're gonna go to iteration 0. We have nothing. So you're gonna so we're gonna append list. Now second iteration, we're gonna append 1 to temp list because that's the first iteration. We're gonna start with 1. We're gonna add 1 here to temp list, and now call backtrack again. So we stopped. So that's the first iteration. We stop when I equals 1. When I equals 1, and then we call backtracking. We call backtracking, but now we can't use 1 again. So we call start with I plus 1. We can't use 1 again because otherwise we would repeat ourselves. So we call 1. Now we're gonna go from 2 to 3, and again we do the for I in range blah blah blah. We're gonna append 2, as you guys can see. So for loop, we are at index 2. Index 2, because that's what index 1, sorry. For loop is at 0 and for loop is at 1, because the element at 0 is 1 and the element at 1 is 2. And that's iteration 1 again as well. Finally, we call backtrack again, just with 3 now. So we call backtracking with start equals 2 and ending equals 3. So we're gonna end 3. And while we're doing this backtracking, observe we're adding it to list. So now list already has this, and now we will have this. Now comes the backtracking. So we've reached this. And then when we call backtracking again, we're gonna call it with 3. Len nums is 3, so we're not gonna so we're gonna append we're actually gonna stop the iteration because we don't have any iteration anymore, right? We're not gonna go even here, so the iteration is not gonna happen. And now we're gonna start popping. So we pop 3, we pop 2. Why do we pop 3 and don't do anything? Because 3 only had 1 iteration, which we did do it, which was 3. I know it's confusing, but you guys have to struggle through this like put this code in your IDE and you have to like think step by step. It is hard. It is hard understanding. It is hard explaining. So I think the Stanford professor gives a better explanation, but I think it's good for you guys to see how you would calculate subsets. And finally, you pop 3. But when we pop 3, we only had one iteration. We pop 2, but when we called 2, we had 2 iterations because our start index was 1 and our index was 3. So, and then we appended, so you guys understand what I'm talking. You append nums 1, right? Now we're gonna go to the last iteration, which is this last element of the loop when we're backtracking. So now we're gonna do append 2, and that's what happens here. So we pop out the elements. Now we're gonna append 2 because it went through the loop, it popped. Now we're going back again for the last iteration of this. And pretty much what we're doing in conceptual level is that thing. We pick, we don't pick, we pick, we don't pick. But not on a tree level. So this is not a tree, it's a different way of solving the problem. We append 2. And then we append 2. We append the element nums2, which is 3. So we append 3. And we call backtracking. But the index is already 2, so we're gonna call 2. We're gonna call backtracking with 2 plus 1. 2 plus 1, which will be our base case because we're gonna call this with 3, this with 3. We can't go through, so we'll start over. So then we added 3. We pop 3. We pop 1. Because all the for loop is over for the second iteration, and then we go for 2. So what we're doing, like if you're not understanding, is this, like we're going here, here, here. If it's not working, we're here, 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 and so on and so forth. We're testing for all the possibilities, and we're gonna pop everything. We're gonna go to element 2 of the first iteration because 1 was already tried. So we pick 2. In the first one we pick 1. We tested for all the possibilities of subsets where 1 is the first element. This 3. Now we're gonna pick 2. We're gonna test for all the possibilities where 2 is the first element. This one only. And that's it. The backtracking thing is always like I'm trying and then I pop. I'm trying, then I pop. So why, you might be wondering why I didn't do like 1, 2, 3 and then like tried this, for example, straight away. Because he's speaking using the index I of the for loop. So I go 2, 2, 3, then I pop. He's unwinding the stack. He pops 3, he pops 2. Now he's gonna try the second loop of this iteration here of the index 2 is gonna be 3. So that's what he's gonna test. He's gonna test 3. And then if we run, we get all the possibilities. I just have this weird thing here, and also I need to, okay. Now we have all the subsets. I hope this was helpful. I think I got a little bit confused explaining, but it's really hard explaining how the backtracking goes. What I would recommend strongly is what I've done here. So try to put on paper like what's going on. First you need to understand recursion. If you don't understand recursion, this is not the right video because this is like an advanced version of recursion. So first make sure you understand recursion. Second, go through the loop. So you go through the loop and imagine what is I at each time I go backtracking. Because when I return the stack from the stack, when I pop the stack, because we reach the base case, we're gonna return here. So we're gonna pop whatever we picked, I, and we're gonna go to 2. And then we're gonna go to 3. So the iteration is picking each possibility. So iteration 1 of the first backtrack call is gonna pick 1. Iteration 2 of the first backtrack call is gonna call 2. And so forth. I hope you guys understood. If you have any questions, just let me know. Join the Facebook group and make sure you watch the suggested videos because it's gonna be very helpful. So, see ya.